Alright, in this video we're going to be looking at bit masking, but instead of reading, as we did in the previous video, we're going to be looking at it in terms of writing to a register. Alright, this is what we want. We want to write to part of a register without, and that's the keyword here, changing the remaining bits. Let me give you an example. I want to change the lower 4 bits, so I want to modify the lower 4 bits of DDRA while keeping the upper 4 bits as unchanged. So let's see how we do this. Let's move down the page a little bit here. So, in the case that we want to set a bit as logic high or a 1, we're going to use the bitwise OR operator. So, let's say this is our original DDRA. And it looks something like this. What we want is to modify the lower 4 bits to all equal 1. And we want to leave the upper 4 bits unchanged. So, how can we do this? Well, we create a mask, just like we did while we were reading, and we put zeros where we don't want to change, and we put 1s to where we want them to go to a 1. And then apply the bitwise OR, and that, just like the read, applies the OR across each of those bits. And we should remember the OR 0 0 0 1 1 0 1 1 0 1 1 1. Alright, so if either bit or both of them are 1, the output will equal to 1. So the result here will be equal to 0 1 0 1 1 1 1 1. Which is what we want. That's unchanged. So that's also what we want. Okay, so how do we implement this in practice? Best way is we go DDRA equals, or equals OX, and then whatever the number is associated in hexadecimal with the mask that you've created. So this one, for example, is OF. Right. Another way of saying that is DDRA is equal to DDRA ORed with OX, OF. Right, both of these are equivalent. This is just the shorthand version, right? Like plus plus or times equals, divide equals, and so forth. Alright, it says take what's in DDRA now, apply our mask to it, modify the bits so we get this result, and then store the result back into DDRA. Right, so that's what we want to do if we're trying to set things equal to 1. However, sometimes you'll want to set things equal to 0. Right? Set bit equal to 0. So we'll take DDRA again, and we'll keep it the same as what we did last time. 0 1 0 1 0 1 1 0. That's DDRA. And this time we're going to apply a different mask to it because we're going to use our bitwise AND. Alright, let's say we want upper 4 to remain unchanged, like before, but we want the lower 4 all equal to 0. Okay, so unchanged 1, 1, 1, 1, and 0, 0, 0, 0. So that's our mask. Apply the bitwise AND to our mask. 0 and 1, 0, 1 and 1, 1, 0, 1, 0, 0, 0, 0. That's good, that's unchanged, and that's the way it worked. Right, and so we could implement that as DDRA and equals, and in this case OXF0. That's the F, that's the 0 there. Alright, or DDRA is equal to DDRA and OXF0. Alright, so that again, when we're bit masking and writing to a register and we only want to change part of the register, then we can apply a mask. If we want to set bits is equal to 1, then we can do things like creating a mask where we want 1s to end up in the destination register, 0s where we want to leave them unchanged, and we use the bitwise OR operator. If we want to set bits as 0, we want all more bits, use a mask. We have 1s where you want them unchanged, 0s where you want them changed to 0, and we use the ampersand character or the bitwise AND, and that is how it's implemented.